Okay, so this question reads, a satellite is moving in circular orbit of radius 9,000 kilometers around an unknown planet where the acceleration of gravity that is acting on the satellite is 9 meters per second squared, going to the center of the planet. And the time to perform one revolution is next to, and then the answer choices. So first we're going to list out the variables we have. So the radius we have is 9,000 kilometers, which if we convert to meters is equal to 9 times 10 to the 6 meters. And then we have the acceleration, which is 9 meters per second squared. So to solve this equation, to solve this problem, we need to use two formulas. So one is that acceleration is equal to velocity squared divided by the radius, and that time is equal to 2 pi the radius divided by the velocity. So we're going to try to manipulate the acceleration equation to isolate velocity so that we can then plug it in to the time equation. So since acceleration is equal to velocity squared over the radius, we could say that the velocity squared is equal to acceleration times the radius, or that the velocity is equal to the square root of the acceleration times the radius. So we can then plug this into the time equation. And so time is equal to 2 pi r divided by the square root of acceleration times the radius. So that's 2 pi radius. The acceleration is 9, so the square root of 9 is 3 times the square root of the radius. So we can essentially factor out here 2/3. So we would have 2/3 pi times radius over square root of radius. R over square root of r is basically the same thing as square root of r times square root of r over square root of r, since square root of r times square root of r is the same as r. So here we can cancel, and so that gives us, to sum up, 2/3 pi times the square root of r is equal to t. So now we can just plug in t is equal to 2 over 3 pi times the square root of 9 times 10 to the 6, which after you plug into the calculator, we get 2,000 pi, which is equal to 62 at 3.19 roughly. And so this is roughly around the 6,000 seconds. Enter C.